Good day. Welcome to WQD 7005 Data Mining Project Part 4 Interpreting the Data. For this project, we are going to predict the share price of Genting Singapore. My name is Junjie, WQD 180009. So for today's presentation, I'm going to cover the following agenda. The first agenda is let us recap the analysis goal. Then we look into replacement of data, and then we look into modeling of data, and finally we try to look at the result and try to interpret the data that we have. To recap the analysis goal, the Genting Singapore stock investor seek to predict the Genting Singapore share price trend. This is done using first, the share price of 4 other tourism related stock in Singapore. Second, the tourist arrival trend in Singapore. And third, the Singapore's air quality data. Using these three information, we try to predict the future share price trend of Genting Singapore stock price. First, we look into replacement of data. So in this process, what we need to do is we want to try to replace the data which does not look correct. And in order to do that, some level of domain knowledge is required to evaluate if the data is reasonable. Looking back in our data set, we realize that the opening price for hotel property, the monthly opening price for hotel properties, there are some records where the opening price seems to be 0. This does not make sense because if you look at the trend, the lowest it was somewhere above 0.86, and it looks a bit weird to have a jump to 0, and yeah, that doesn't make sense. So what we need to do here is we need to run this algorithm to replace this data that doesn't seem correct with a missing value. So how do we do that? So previously from the histogram we can see that the opening price was never less than 0.5. So what we can do here is we go to the interactive replacement interval filter, we pick up the field that we want, and we change the limit method from default to user specific. And what we want to do here is we want to put a lower limit which tells the system, says that hey, if the data is lower than this probably doesn't make sense and we should try to replace this with some other value. Let us see how we can do that in Enterprise Miner. So this is the replacement. So what we want to do is we want to replace the value with a missing value, and in order to do that, what we will do is we open the replacement editor, okay, and we look for the field that we see from histogram. From our first eye view, the data doesn't seem correct. In our case, the hotel property month open price doesn't seem correct because it has a value which is 0. So what we do here is we take this field, we update the limit method to user specified, which we already tell that we want to replace the value with missing. And what is the limit that we want to use is the lower limit is 0.5. So this will tell the system, if you run this thing, if you see anything data that is 0.5 and below, so replace that with missing value. Okay, and let us try to run that. Alright, so once we run this, we will be able to see the result coming out in the report. Let us wait for a second. Alright, now the replacement has been completed. We can go here and look at the result. So what we see here is this is the summary of the replacement that had happened. And we look at this, very good. It seems there's no replacement happened. So why we have this is because the field that we have selected, I have previously rejected that. So the system is so smart that it doesn't try to do replacement for the fields that we have rejected. Let me show you what happened again. So if you look at this, the hotel price open is rejected. I'll come to why we do this in the second. Alright, so that is the purpose of doing the replacement. Okay, let us go back to our slide. Okay, so this result was taken before I changed the role of those fields. So if those field is selected, is accepted as an input, so this is going to be shown in the report. It says that one observation for this variable and the row of this is input, and this one observation has been replaced. Alright, so what we can do is we can further explore the output of this replacement by going to the exported data, train, and look at this field. This new field will be created, and you show that now the minimum value for this is 0.92. Previously there was a value of 0. Alright, to see the exported data, what we can do is, let's go back to our SAS. We will come to this replacement and we look at the exported data. This will show us the value of the data that's been exported. And let's look at train and explore. Okay, let's wait for a while for it to run in the background. Okay, here's the output, and we can see that these are the minimum value, maximum values of each of it. And for the hotel prop open price, there is a minimum value of 0. So since this field has been set as rejected, so the system doesn't do anything to do the replacement. Otherwise, we should be able to get the result as what I've seen in my screenshot. As we see in this screenshot here, there will be a new field created called REP, which stands for replacement, and this will be the field name, and the label is replacement. Alright, moving on with the slide. So once we have completed the replacement of those data that doesn't look correct, we can start to do our modeling. So what is modeling? Modeling is for us to set up the system so that it can do prediction. And typically for prediction, there is 3 different kind of prediction that we can do with SAS minor. So the decision, which sets the result to some classification, whether it is on or off, or up or down. So that will help us to make our decision. Other than that, it also support ranking and estimates. So for this purpose of this project, we are going to use decision. Alright, so next, we need to look into how many inputs in our modeling data. Why we want to do that is we don't want to create too many dimensions of the data, which makes the decision tree too complicated. So in our data sets, if you look at it, the number of columns available is 51. There are 51 features available for this. And what happened is some of these features are related to each other. They could be pretty redundant. So the next step, what we need to do is from this 52, we try to do an input reduction or reduce the redundancy, because some of the data are raw data which we have already computed to get a more meaningful data. For example, I have the max PSI value, and I also have the air quality index level. So these two is highly correlated because they are basically the API value is the API level is computed from the max PSI value. So I only need to get one of these field, because if I use these two, the system may think that they are highly correlated and may be using the wrong field for the decision making. And some other things are the month open price and the month end price is pretty redundant because we already have created a new field called trend. You can refer to my previous presentation for that. And also the tourist arrival for current months and tourist arrival for previous month is redundant because there is a new field that we have computed to show the trend, which is the comparison of these two values. So what I've done here is I will go back to the variables, and I'll find all the features or that does not contain the name trend. and I'll update the use to no. And similarly, for those that has the field name has trend, Africa trend, America's trend. So these are the comparison from the previous month to the current month. So I'm going to use this. So I'm going to set all these use to yes. Alright, then next what we need to do is we need to partition the data that we have to have different set data used for training and validation. So out of all the rows observation that we have, we want to partition them to say, okay, use some of them for training and use some of them for validation. Let's see how we can do that. So we go to partition. Once we create a partition, so we're going to allocate some of the data. In this case, 70% of my data will be used for training, and I'll use another 30% of data for validation, and none will be used for tests. So the reason why I'm using 70% so much of data for training is because the data set that I have, even though it was originally it was a lot, but after I reduce all the data to month, and since it's only month, so I only have data for the past 10 or 12 years, and that results to about 130 rows of data only, and that isn't too much of data. So that's why I need to allocate more of the data for training and a little bit lesser for validation. So once I've done that, I can run this, and okay, after the running has been completed, we can look at the result, to look at the report. So this report tells us, so in total there are 130 rows, and 90 rows will be used for training, and the other 40 rows will be used for validation. Okay, and the target for that we are going to use here is the Genting month trend, which we want to try to predict whether the price of Genting's share for the month it will go uptrend or downtrend. And this tells that in the total data that we have, about 50% of them are downtrend, 46 are uptrend, and from the sampling, 70% used for training, it will be in this breakdown, 54% is in downtrend, and 45% will be in uptrend. And the data used for validation, there will be 52% used which are downtrend, and 47% of data will be of uptrend for validating this. Right, let's go back to our slide. Okay, now let's see the result of this. So once we have set up the data partition, we can plug in the decision tree for this. Okay, once we have plugged in the decision tree and connect to it, so we can try to run the decision tree and see the result. Alright, so let's wait for this interactive decision tree to be opened up. So this function of the interactive decision tree allows us to go through the step-by-step process how the tree is being created. So if you are lazy, what we can do is we can do train node, which will do all the decision tree breakup for us, or we can split it out. Let's kill everything first, or we can try to split the node level by level. So when we split the node, what is going to happen is it is telling me that based on all the fields which are available, or the trend which are available, it find out which are the one that has the highest gain compared to the Genting share price. So it sees from here that the escort month trend, so it has the highest entropy, and we can use this one to split the data. Okay, so this will split the decision tree into how many of it are uptrend or missing, and how many of it is downtrend, based on the escort month price. So you can see that the Genting share price and the escort share price is quite highly correlated, because when the escort share price goes down, so most of the Genting share price goes down in the training, and the same goes for the validation. And when the escort month trend goes up, you can see that the share price for Genting, most of it goes up trend. And for validation, there's a 58% of accuracy here. And then we can further split this. Okay, since the gain following to this wasn't so much, we may not want to try this. So let's try on this side of the branch to see if we can further split this. Alright, we can see that the Mandarin month trend seems to be quite closely related as well, because it has the highest entropy here. Supply here, and we can see that when the S-corp price goes up and the Mandarin price goes up, 80% of Genting price is going uptrend in the training set and 66 in the validation set. And when it goes downtrend, so 57% of the Genting share price goes down as well. So this is how the decision tree is being made. So let us print this node and we use the automatic train node for it to build. So here's the result that gets built. And let us view the subtree assessment plot. Let's see what happened. Okay, we can see that from here, the blue line is the training data. Okay, the training data will always go down for it, the error for this will always be reduced, because whenever a new branch is being created, we are getting a more accurate view of the split. However, having it too accurate, there's a downside to it, because that will cause overfitting. So what means by overfitting is, if you see here from the test, the validation data shows that it is quite accurate for 2 number of leaf, but as we go to 3 number of leaf, it is still pretty okay. But when we go to 4 number of leaf, see that the error goes up. Okay, and even though the training shows that when we have 4 level of leaf, the error seems to be going down, it shows the different behavior in the validation. So we should take this into consideration. So based on this, we can say that the accuracy of our model based on the validation data is about there is about 37% chance of failure, which is about accuracy of it would be about 62.5 based on the validation of data. Alright, so let us see. So this is the result after we strip off all the redundant data. So I've also run the experiment without removing all the redundant field. Okay, without removing all the redundant field, so this is how the tree is going to look like. So it's going to be more complicated. Okay, but however, if you look at the validation seems to be very, very poor. If you see here, it lingers about 40% of errors, even though in the training set is improving a lot until it reached 7 leaf. It is like close 90% of accuracy, but when we test this against the validation set, it is pretty bad. So the error is about 40%. And just to play with this, what I did was I changed the target. So the target for this project is the Genting share price trend for the month. And just to play with this, I've set the target to the air pollution level and to see what happened. So when we see here, this is very interesting. If I change the target to air quality as the target, so it shows that when I run this decision tree, the result is pretty good. So if we go a number of leaf up to 4, so we can get about, the error rate is about 15% of error rate, which is about 85% accuracy. And if you look at the tree says that it's a bit too small, but then it is split by the hotel price, closing price, and it's split by the number of tourists from America. Yeah, so this is how the data is being split out. So it seems to tell us that the air quality data is correlated with the others share price and the tourist arrival. which if you look at it from the common sense point of view, that is totally not true. So we need to be very careful with our selection so that we don't make a wrong assumption here. So what I want to point out here is a correlation does not imply causation, because it could be the other way. Alright, that's the end of my presentation. Thank you.